Hello, this is my presentation on obesity awareness in Corpus Christi, Texas, by me, Emily Brennan. So I'm going to start with a basic introduction into the project, that there is non-Hispanic Black females and Hispanic males and females who are most afflicted with obesity. The obesity prevalence in Corpus Christi, Texas is expected to climb to 50% by 2030 without interventions. And obesity is associated with diseases like diabetes, cardiovascular disease, stroke, and some cancers. Having a high body mass index, or BMI, accounts for 4 million deaths globally, with about 40% of them occurring in individuals that were not considered obese. To continue, the purpose of this study is to use survey data to investigate if residents are aware of their weight categories, specifically interested in obesity awareness. This study is novel in that to our knowledge, it has never been performed, let alone has it been performed in the study area of Corpus Christi, Texas. So we're going to use geospatial analyses to explore if there are differences found between the perceived and reported weight categories, where we hypothesize that there will be no significant differences between perceived and reported weight categories. And as most of you know, Corpus Christi, Texas is located along the Texas Gulf Coast. It's located in South Texas, and it is characterized by coastal landscapes, which make it a very popular tourist and recreation destination. If we think about this in the related to counties, we have the Corpus Christi as the largest city in Nueces County. Corpus Christi also has a pretty decent sized population of about just over 300,000. That is according to the 2022 U.S. Census. And in the study area, the largest ethnicity category is Hispanic or Latino. And the U.S. Census Bureau also has a little caveat that says that the Hispanics may be of any race. So the data was collected via Qualtrics surveys between February 2020 and May 2021. The only requirements of the survey were that you are at least 18 years old or considered an adult, and that you live in Corpus Christi, Texas. The total number of participants started out at 405. After cleaning, it came to 332, and then those with home addresses that we could geocode was about 172. And we also collected the perceived, reported, and measured weight categories from height and weight calculations for BMI by the WHO standards. Those were normal, overweight, and obese. Okay, so now I'm going to talk a little bit about our methods, and I have several slides on this to talk about a little bit about each method separately. But I want to mention that we used ArcGIS Pro to visualize and perform the statistical analyses. We have abundance of zip code data for each respondent or each participant, but it was harder to perform the analysis on the zip code data because it would just be points and showing clusters of points at one location that's represented by that zip code on a map. And so we elected to use home address information so that we would have a little bit more variety of where the data is coming from. And we adjusted the weight category into a binary format where 1 was equivalent to being obese, 0 was not obese, and then we had that information, that data subset, imported into ArcGIS Pro, and we geocoded it, and then performed a spatial join with the zip code layer, polygon layer, the geocoded data layer to be able to perform hotspot analysis. Okay, so I'm going to talk a little bit about the hotspot analysis first. A hotspot analysis is also referred to as the GEDIS or GI star. It shows localized clustering intensity, which does not show a relationship direction. And it's also a statistical analysis that visualizes and identifies statistically significant hot and cold spots. They are usually showing the z-scores when you see the hot and cold spots, which is what you see here in the middle after where it says z-scores after input. And the higher or lower the higher or lower the z-score is, the more intense the clustering. So it uses a fixed distance band to conceptualize spatial relationships. It's best to use it with point data, and it ensures a consistent scale of analysis. The next method we used was kernel density estimation. And I mentioned this in the proposal for the project, and it was kind of it seemed like it wasn't the best choice for the zip code data, but since we could use it for spatial distributions, I thought we could use this for our subset of data that was the geocoded home addresses. And the kernel density estimation is also called KDE for short. It's used to calculate the density of point and line features, which we had point features, and it's commonly used in crime analysis and public health. So the final method that we used for spatial analysis was spatial aggregation, which is a form of visualization that uses statistical methods to summarize groups. It shows both high density and low densities, and high density and clustering is associated with higher values, whereas the lower values show low density and sparse clustering. So I'm going to talk a little bit about the results, which here this slide shows every result that we got from the spatial analyses, with the exception of spatial aggregation. And I'll talk about spatial aggregation in a future slide. Excuse me. And so for hotspot analysis, we saw that the perceived weight category had not significant results. In other words, they had no hotspot and no cold spots represented. But there was a hotspot and a cold spot for 78417 and 78418, respectively, in the hotspot analysis for the reported weight category. And both of those were at 95% confidence levels. And for the kernel density estimation, we saw some darker colored cells, which in this case, for our visualization of the map, were showing higher values of clustering. And I will show those maps here momentarily. That was for the perceived weight category. And the reported weight category showed some different darker colored cells. In other words, they showed different zip codes for perceived weight category and for reported weight category. Okay, and I'm going to briefly show the results, the resulting maps, visualizations of the results that I just discussed. So here is the map of hotspot analysis for perceived weight category, where it showed no significant cold spots or hot spots. This is a map of the reported weight categories, showing the cold spot at 78418 and the hot spot at 78417. These are both, according to the legend, 95% confidence levels. And the green areas in both of these maps are just there to show the polygon layer, zip code layer represented. These are areas where no data was evident. This is the map of the the perceived weight category for the kernel density estimation. Here, it's a little confusing, and I didn't think about this until I am now recording. But the green here does not mean that the data is not present. It just means that that's the polygon layer of each zip code represented in Corpus Christi, Texas. So we see some of the darker areas in 78405, 78417, where there were higher values of clustering. And this is the KDE for the reported weight category, showing a little bit different zip codes included than were shown with the higher values, the darker areas with higher values from the previous map. Okay, and here's spatial aggregation analysis, statistical analysis. This one may be a little challenging to see, but 78417 is the only zip code that shows a high value of high density clustering, and it shows a lot of zero values in the yellow areas. And again, for this map and the upcoming map where spatial aggregation was performed, the green areas indicate areas of no data. For this final visualization of spatial aggregation, we see a lot more red areas, which are associated with higher values, so higher density and more clustering. And we can see that 78417 here is also represented. So that's kind of interesting. To discuss a little bit about our results on this slide, I read a paper by Klinik and Crisp, which indicated that hotspot analysis and KDE together yielded effective and efficient results in interpretation. But in my opinion, the results using both those tools yielded mixed results and didn't appear to complement each other in the way that their paper indicated it would. So our hotspot analysis showed no hotspots, no cold spots in the perceived weight category, but it did show a 78417 hotspot and a 78418 cold spot. So it was kind of hard to make any interpretations of the hotspot analysis. And we saw in the maps there was more perceived obesity indicated in the darker areas of the kernel density estimation, indicating higher values of obesity points, and the same with the reported obesity, but they were in different zip codes, so there was no overlap on them. The spatial aggregation was the only one that showed some really obvious evidence of a lack of awareness between perceived and reported weight category. The only explanation, I forgot to mention this a second ago, but the only explanation I can think of for the perceived weight yielding no significant hotspots or cold spots in the hotspot analysis was that the data may have limited variability or could be influenced by non-spatial factors, maybe sociodemographic information, environmental, cultural, even. Some final concluding remarks is that, as I mentioned previously, the results of the hotspot analysis and the KDE did not appear to complement each other. The spatial aggregation tool revealed more of a trend or pattern in the data that indeed showed evidence of a lack of awareness in Corpus Christi, Texas. The hotspot analysis failed to demonstrate statistically significant obesity patterns for perceived weight category, and that may be due to reasons such as environmental, cultural, or even socioeconomic factors. For future studies, I'd like to see us go to the areas that were not represented as well in the study, as well as attending even more health events, maybe even in a future survey, including some definitions of obesity and finding out more information about what other residents consider obesity to be. And then in the future studies, we will analyze neighborhood aspects such as recreational facilities and healthy food access. Thank you so much for listening to my presentation. And here's a list of references used for this presentation.